Good afternoon and welcome to today's Mechanotechnics N6 webinar hosted by Macmillan and Chopin Publishers. My name is Gyan Krishna. I'm the National Sales Manager for TVET. At Macmillan Chopin, we are committed to supporting lecturers in implementing the new curriculum. These webinars have been designed to cover all the changes required as you tackle the new curriculum in your classrooms. Our presenter today is a seasoned lecturer and marker. His name is Vishal Dukhi. He's based at Majuba TVET College, and it's over to Vishal to start the presentation.
Thank you, Gyan. Hello and welcome to this webinar concerning the curriculum changes you need to prepare for in 2021 for Mechanotechnics N6. As Gyan had said, I am Vishal, a lecturer at Majuba TVET College. I have to date 15 years lecturing experience. I have many years of experience as a marker and a material developer for lecturer development workshops held all over the country. I'm also an author of Strengths of Materials and Structures N5. The main differentiating factor with this whole series of TVET first books is the manner in which they have chosen to present the content of the books. Concepts are presented in a way that promotes real understanding without distorting the facts. All worked examples and activities have been carefully chosen to ensure that students succeed in their exams. In this webinar, I want to briefly review and discuss the new curriculum outcomes for Mechanotechnics N6. We will also discuss how this affects the learning content, your academic year, and your assessment. Then show you how the Macmillan TVET first books for Mechanotechnics will support your teaching. As you may know, the TVET curriculum for many subjects have been reviewed and updated by the Department of Higher Education and Training for implementation in 2021. Let's have a look at what these changes are for Mechanotechnics N6 and how they will affect your teaching. The general aims of the curriculum is slightly more advanced and aims to build on the aims of the N5 curriculum. Mechanotechnics aims at teaching students to familiarize themselves with practice and calculations that may occur in their work situations. It also aims to create opportunities for lifelong learning in the mechanical engineering profession, which will result in a meaningful educational experience, enabling the student to take up his place in the mechanical engineering field. The specific aims of the curriculum in Mechanotechnics N6 are to equip artisans, mechanical engineering supervisors, designers of projects and equipment, engineers with the necessary mechanical engineering knowledge to implement well-defined mechanical projects. The N6 curriculum is a culmination of 3 trimesters of exposing students to the trade of a mechanical engineer. The prerequisite of the N6 curriculum is a student must have passed at least the National Certificate N5 Engineering with Mechanotechnics N5 as a subject. If we look at how a student is evaluated in this course, evaluation is conducted continuously by means of class tests, an internal continuous assessment mark of at least 40%, as well as a minimum examination mark of 40% is required to pass the instructional offering. The ICAS mark and the examination mark will be calculated together in a ratio of 40 to 60 to derive the promotional mark. That is 40% ICAS and 60% final examination. The examination in Mechanotechnics N6 will be conducted as follows. There will be one paper that is to be written. All modules will be tested with different weightings from module 1 to 8 to get a total of 100. The duration of the examination is 3 hours. In terms of the weightings of cognitive levels, questions will include recall, comprehension, application, analysis, synthesis, and evaluation of all the learning content. These are important aspects in determining a student's knowledge and understanding of the new curriculum. The following weights are consequently awarded to each category. Knowledge and understanding will count between 10 and 25% of the total marks. Application between 30 and 40% of the examination mark. Analysis, synthesis, and evaluating will count between 20 and 35% of the total marks. At this juncture, I would like to take a minute or two to cover the basic workings of Bloom's taxonomy. This is very important to both learner and educator. In one sentence, Bloom's taxonomy is a hierarchical ordering of cognitive skills that can, among other countless other uses, help teachers teach and students learn. The framework was revised in 2001 by Lauren Anderson and David Cratwall, yielding the revised Bloom's taxonomy. The most significant change was the removal of synthesis and the addition of creation as the highest level of Bloom's taxonomy. And being at the highest level, the implication is that the most complex or demanding cognitive skill, or at least represents a kind of pinnacle for cognitive tasks. There are many reasons for the popularity of Bloom's taxonomy. For now, it's clear that many educators love Bloom's taxonomy because, among other virtues, it gives them a way to think about their teaching and the subsequent learning of their students. The framework can be used to create assessments, evaluate the complexity of assignments, increase the rigor of a lesson, simplify an activity to help personalize learning, design a summative assessment, plan project-based learning, frame a group discussion, and many, many more, because it simply provides an order for cognitive behaviors. It can be applied to almost anything. So colleagues, my advice would be to please familiarize yourself with Bloom's taxonomy and see how you can use Bloom's taxonomy in your teaching, because I can guarantee you that it will definitely assist your learners. Let's look at the changes that are made to the new revised curriculum. We will do this by going through the outcomes of each module and by highlighting the changes per module. Topic 1 covers the learning area of clutches. It has a weighting of 10% in the final examination. The general aims of this module is to ensure that students are able to identify primary functions of clutches, understand the theories of plate and cone clutches, and to do advanced calculations from basic principles. Looking at the learning content and specific learning outcomes for this module, as outlined by the curriculum document, we can identify some of the changes that have been implemented. Let us go through the learning outcomes for Module 1 so as to gain a better feel for the content adjustments. Under your learning content functions, students should be able to draw and label a multiplate clutch. They must also be able to explain the uniform wear theory and the uniform pressure theory. In terms of advanced calculations from basic principles, students must be able to calculate the force required to press the plates together, the number of contact pairs required in a plate clutch to apply the required pressure, the combined speed between the engine and the shafts at the moment of no slippage, total time of slip, total time of a shaft to reach certain speeds. They must also be able to calculate torque retardation torque of an engine or shaft, and combined speed. Under the learning content of the theory of plane and cone clutches, plate clutches, and conical clutches, the students are required to be able to define conical clutches and explain their applications. They must also be able to calculate various physical quantities such as torque, the total axial to engage the clutch, moment of inertia, angular velocity, angular acceleration, time, the maximum pressure, and pressure for the inner and outer diameters. Looking at centrifugal clutches, students must be able to describe and explain the application of centrifugal clutches, calculate centrifugal force, forces on springs and frictional forces, calculate torque, angular velocity, mass of shoe, or power. Topic 2 covers the learning area of brakes. It has a weighting of 10% in the final examination. The general aims of this module is to ensure that students are able to identify and know the primary functions of brakes. They must be able to distinguish between the different types of brakes and do advanced calculations from basic principles. Going in some detail of the learning outcomes for this module, students must be able to explain the basic principles of brakes. They must be able to list the design elements that are applied in brakes, in brake design. Looking at band brakes, students must be able to list and explain the two types of band brakes. They must be able to draw a label diagram which shows the theory applicable to flat valve drives and centrifugal forces. They must be able to calculate physical quantities such as the tension ratio, torque, moments, power, vertical components, number of revolutions, time, angular velocity, the work done, and the minimum coefficient of friction. Moving on to the block brakes, they must be able to define and explain the application of block brakes, calculate the coefficients of friction, forces, normal reactions, power, the diameter of the disc, torque, time, number of revolutions, the drum diameter, number of turns, and maximum braking torque. Under the learning content of block and band brakes, the students should be able to describe band and block brakes, explain the structure of a flexible steel band with the aid of a label diagram, calculate minimum forces, moments, power, distance, time. They must be able to dissolve forces on the radius and dissolve tangential forces as well. Moving on to module 3, which covers the content on line shafts. This module has a weighting of 10%. The basic aims of this module is to ensure that students are able to identify primary functions of line shafts and also to do advanced calculations from basic principles. Module 3 broken down is as follows. Students should be able to list the basic principles and functions of line shafts. They must be able to list the factors that should be considered when selecting line shafts for specific functions. They must be able to calculate torque, power, shear stress, shaft diameter, and shaft speed. Calculate reactions on the horizontal and vertical planes. They must be able to identify and work with the tight side and slack side valve tensions. They must draw label diagrams to illustrate the calculations, list types of gears and their applications thereof, list the forces that must be considered when two gears mesh, and they must be able to draw a label diagram and explain the pressure angle between the two gears in mesh. Under the learning content of gear drive calculations, Students should be able to list the types of gears and their applications. They must be able to list the forces that must be considered when two gears mesh. Draw a label diagram to illustrate the direction of forces when gears mesh. Draw a diagram and explain the pressure angle between the two gears in mesh. They must also be able to calculate vertical and horizontal reactions in bearings, the torque transmitted, power transmitted, and tangential force between gears, radial force, and belt tension. Moving on to Module 4, which covers the content based on flywheels. This module counts 10% of the total marks. The aim of this module is to ensure that students are able to identify primary functions of flywheel types and also to do advanced calculations from basic principles. Looking at Module 4 in detail, we find that the student will be required to perform an array of calculations to find various physical quantities. The learning outcomes for Module 4 are as follows. Students should be able to list the basic principles and functions of flywheels. Under the calculations for flywheels, students should be able to calculate the moments of inertia, the mass, radius of gyration, angular acceleration, linear acceleration, number of revolutions, pulley or flywheel diameter, the time, pulley radius, kinetic energy, potential energy, displacement, linear velocity, tangential acceleration, frictional torque power, mass, percentage of error, rotational speed, and loss in kinetic energy. So as we can see, colleagues, there's a huge array of calculations that students must be able to perform in this module. Moving on to Module 5. Module 5 is based on reduction gearboxes. This is a follow-up from the N5 curriculum. It has a topic weighting of 10%. The general aims of this module is to ensure that students are able to identify primary functions of reduction gearboxes and to do advanced calculations from basic principles. The learning content and outcomes for Module 5 are as follows. Students should be able to list the basic principles and functions of reduction gearboxes. They must be able to draw a label diagram to illustrate wheel and pinion in a gear train. They must be able to define the term gear train and give examples of gear trains and give their applications as well. They must also be able to calculate physical quantities such as torque required for acceleration, efficiency of gears, equivalent moment of inertia, input and output torque, resisting torque, and the total kinetic energy. If we look at the learning content where we look at acceleration of gear trains, and we will look at the simple gear trains as well as the compound gear trains, students should be able to explain the working principle of worm gear drives. They must draw well-labeled diagrams to show single start worm and double-threaded worm gears. They must be able to calculate the PCD, peripheral velocity, end thrust, and number of teeth on the worm wheel, gear ratios, center distances, reduction gear efficiency, and frictional torque. Excuse me, they must also be able to calculate the number of threads on worm gears, effort, distance moved, and velocity ratios. Module 6 covers the content of rail traction and vehicle dynamics. This module was introduced in the N5 curriculum and carries forward to the N6 curriculum. It has a weighting of 15% in the final examination. The general aims of this module is to allow students to identify primary functions of rail traction and vehicle dynamics, and also to do advanced calculations from basic principles. If we have to look at the learning content and outcomes for Module 6, Students should be able to list the basic principles and functions of all rail traction and vehicle dynamics. They must be able to explain the purpose of ballast and automatic track lining machines, explain the effect of centrifugal forces on vehicles traveling around curves. They must also be able to explain the meaning of the following terms: rolling resistance, inclined resistance, acceleration force, components of weight parallel to the incline, and acceleration forces. They must also be able to define locomotive tractive effort and drawbar pull. For calculations, students need to be able to calculate the speed on level tracks, acceleration, deceleration, upward movement and downward movement for constant acceleration and deceleration, total locomotive force, wheel speed, locomotive tractive effort, locomotive power, tractive resistance, acceleration force, time, average power developed, the drawbar pulley, grade resistance, braking forces, energy dissipation, retarding force, axial torque, gear ratio, velocity ratio, number of drives, mass, transmission losses, and maximum speed. Under the learning content of skidding and overturning on curved tracks, which was also covered in the N5 curriculum, students should be able to list the formula quantities, symbols, and basic SI units of measurement used on skidding and overturning on curve calculations. They must be able to define the following terms: unbanked and banked tracks, unbanked curves, and banked curves. There's an array of calculations that they should be able to perform. They must be able to calculate maximum speed without skidding and overturning, coefficients of friction, moments, super elevation, maximum speed, side thrust, minimum radius of unbanked curves, banking angles. They must also be able to calculate the mass, centrifugal force, centers of gravity, height of center of gravity above the track, and frictional resistance. Under the learning content for vehicle dynamics, they must be able to list the basic principles and functions of vehicle dynamics. They must be able to list 3 opposing forces that affect tractive effort at constant speed, list the quantity symbols and basic SI units that are used in the calculations on vehicle dynamics. They must be able to define the following terms: power, tractive effort, engine torque, etc. And under calculations, they must be able to calculate the input and output power, engine torque, axial torque, tractive effort, gear ratio, transmission efficiency, braking torque, deceleration, engine power on level roads, engine power on inclined planes, angular velocity, magnitude of the balancing couple, angular retardation, load transfer, weight, maximum possible acceleration, and a few others as well. Moving on to Module 7, based on static and dynamic balancing. This module has a weighting of 15% in the examination. The general aims of this module is to ensure that students are able to identify primary functions of static and dynamic balancing types, and also to be able to do advanced calculations from basic principles. Going into detail on the learning content and outcomes for Module 7, the learning content covers balancing of a single rotating mass, balancing of several masses rotating in the same plane, and balancing of rotating coplanar masses. The specific outcomes require the students to be able to explain the concepts of balancing of single rotating masses with the aid of label diagrams. They must be able to calculate the centripetal acceleration, the thrust on front bearings, centrifugal force, and the balancing of a mass. They must also use labeled diagrams to explain the concepts of balancing of several masses rotating in the same plane. They must be able to explain the static dynamic balance. They must also make use of labeled diagrams to explain the concepts of balancing of rotating coplanar masses. Balancing of masses rotating in different planes, where we will focus on Dalby's method. Students must be able to, again, with the aid of label diagrams, explain the concepts of balancing of several masses rotating in the same plane, and with the aid of label diagrams, explain the concepts of dynamic forces at bearings. They must also be able to perform calculations such as the axial distance between planes of revolution, angles, and masses. They must be able to construct couple polygons and force polygons. They must also be quite adept at calculating the value of couples, dynamic loads on bearings, relative angular positions, distance, value of unbalanced couples, and magnitude of bearing reactions, direction of reactions, and minimum and maximum vertical forces. Moving on to the last module, kinematics. This module has a topic weighting of 20%. The general aims of this module are to ensure that students are able to identify primary functions of static and kinematic types and do advanced calculations from basic principles. Going into more detail of the learning content and specific outcomes for Module 8, if we look under the learning content of motion, specifically the students should be able to define the concept of relevant motion. They must list 3 quantities of motion, list 3 types of motion, use label diagrams to explain the difference between linear motion and angular motion. They should be able to define the following terms also with the aid of diagrams: machine kinematics pairs, mechanisms, inversion, relative velocity, acceleration, kinematic chain, 4-bar chain, and the slider crank chain. Under the learning content of relative velocity and acceleration, centripetal and triangular acceleration, learners are specifically required to be able to define the terms centripetal and angular acceleration. They must also be able to draw diagrams and show the calculations for centripetal and angular accelerations. They must be able to calculate tangential accelerations, calculate centripetal and tangential components. They must also be able to define the terms centripetal and triangular acceleration. They must make use of label diagrams again and apply the calculations for centripetal and triangular acceleration. They must be able to calculate tangential acceleration and calculate the centripetal and tangential components. Under the learning content of acceleration links, students are specifically required to be able to define the concept of acceleration links. They must draw and label acceleration diagrams, label the parallelogram of forces on centripetal and tangential diagrams, calculate velocity, angular velocity, and angular acceleration, and also indicate the direction of rotation. They must be able to draw a labeled perpendicular and horizontal line on the acceleration diagrams, calculate linear velocity and linear acceleration. They must be able to sketch a fully labeled space diagram according to scale and find the instantaneous center, draw and label a velocity and acceleration diagram, and apply the angular acceleration of links and linear acceleration of sliders. They must also be able to draw a fully labeled velocity diagram and apply vertical velocity. A few suggestions of some of the ways the curriculum needs to be presented so as to achieve the desired outcomes envisioned in the curriculum. The theoretical principles should be applied to practical real-life situations. Discussions and evaluations should be done on the basis of real practical workshop situations. Although the art of effective listening could be formally introduced and refined in oral work, it should be practiced continually and become part of the student's way of life. Excursions, videos, and interviews could all contribute to an understanding and evaluation of the Mechanotechnics curriculum. Having a look at the Macmillan TVET First Mechanotechnics N6 textbook, the module and units of our book are aligned to the curriculum and use the same topics and subtopics. We're going to take a look at how our book can help you in the classroom. It is full of useful features that will help you and your students to navigate your way through this new curriculum. Each module starts with an overview box that introduces the content to be covered in the module and lists all the learning outcomes from the curriculum document. This is very useful as it also serves as a gauge for the students to check against to determine their readiness per chapter, as well as for the lecturer to make sure that he or she has adequately covered the content that is required. The overview box is followed by a starter activity, which is normally a class discussion designed to introduce students to the content by relating it to things that they are already familiar with. A summary of the content of each unit of each module is included at the end of the module, highlighting all the key points. These are excellent revision tools that can be used by the students. We have used easy to follow explanations in simple language throughout, particularly for difficult sections. In some places, the book goes beyond the requirements of the topic in order to enhance understanding. This trend also allows for the foundation to be laid if a student wishes to pursue the mechanical engineering field in a qualification beyond Report 191. The explanations and diagrams are clear and written in a way to promote understanding, and explanations can be followed on the clear diagrams which allow the students to visualize the explanation. Photographs help with students' understanding and link what they are learning to the workplace. The gray information boxes are used throughout the book to highlight the important formula and important rules that the students need to remember. Each module is concluded with a summative assessment. This is indispensable for revision and exam preparation and are modeled on exam type questions. The lecturer's guide is also very useful and valuable to you as lecturers. We will briefly go through some of the key features of the lecturer's guide. The lecturer's guide includes some curriculum mapping, which includes a lesson plan template and a suggested 10-week teaching plan so that you can keep track of your content coverage and plan efficiently. We also have various classroom management tools and preparation tools to ensure that you are efficiently and adequately prepared for the lesson. We also have detailed solutions to all the activities, which are invaluable to you as a lecturer and will ensure that your students are able to receive their full potential in this instructional offering. Thank you, colleagues. We have highlighted the significant changes to the Mechanotechnics N6 syllabus for 2021. I hope that this webinar has helped you in some way. And if you have any questions, feel free to ask questions and we will try our best to answer them so that you are able to navigate your way through this new curriculum. Thank you, Gan. Back to you.
Thank you, Vishal, for an in-depth and a very interesting presentation. I'm sure it's going to be of great benefit to the lecturers. So we have the opportunity now to engage with Vishal in terms of any clarity you're seeking. So if you could just unmute yourself and pose your question, we'll give you an opportunity to do so. We will also be sharing today's presentation so that you could always go back and review it and even pause certain sections that you just want to get a greater understanding of. So that should come through tomorrow sometime.
Gan, if I can just maybe also, just help our colleagues a little bit. What I've noticed from experience is that these concepts that the modules are covering in terms of, like, for example, clutches, brakes, line shafts, and so forth, becomes really difficult for some students to see what is happening. So I would urge our colleagues and our colleges to get models of these things so that students could identify physically on a model the components that are required. And if they can envision the components, then they have a better understanding of how the mechanisms work, and they are able to perform a whole lot better in the calculation questions as well. So I found from experience that having a module or a model or an actual, for example, brake band or block and band brakes example, really helps the students to perform better in the questions.
Yeah, that's a great suggestion, Vishal. Lecturers, I think you need to take that on board. And if it's benefited Vishal's students at Majuba, I'm sure the same would happen in your college as well. So we just want to give you a few more moments to just gather your thoughts and then to pose your question. And if there's nothing further, then we'll close today's webinar. But we just want to give you a few more minutes to think about what you're seeking clarity on. Vishal, I don't know if you just want to provide any other suggestions you may have, or draw from your own experience that may be of benefit to lecturers whilst we're waiting for questions to come forward.
Yeah, again, one of the other things that I've picked up from my experiences is that because of the time constraints of the curriculum, and I know that although it's a suggested 10-week or 12-week curriculum, colleges seldom have more than 8 or 9 weeks to prepare the students to sit for the examinations. So a lot of the time what you find is that students lack certain prerequisite knowledge for certain topics. And if we look at the new curriculum, we'll find that the last 3 modules basically are more weighted in terms of the total marks. So, I would really look at those modules and try and see whatever knowledge is required for a student to be able to perform well in those topics. And it would not be a waste to go back and maybe refresh on certain N5 concepts and even maybe N4 concepts that will assist students to understand these things better, especially under the section of kinematics, which requires students to be able to draw force polygons and space diagrams, etc. Sometimes you might even need to draw back on some of the knowledge from the Science N4 syllabus to assist the students here in the N6. So it would not be a waste, in my opinion, to actually go back and find the prerequisites that students need per module and spend a little time ensuring that the students are familiar with those concepts and are able to apply them into or integrate them into the N6 syllabus.
Thanks for that, Vishal. There's no questions, so if you have nothing further, I think we should close today's session. Just some closing remarks from you, and then thank you for attending today's webinar.
Okay. Colleagues, I wish you all the best in implementation of the new curriculum. Remember that GAN will post up onto our website the curriculum documents. And if you guys have any questions, feel free to post them or send GAN an email. And I'm sure that, you know, even if we don't have the answers for you, we will definitely do our research and be able to give you an answer in some time. Just also remember that the new curriculum is going to be implemented in the third trimester of 2021. So the end of year examination in the third trimester, we can expect examination papers to be aligned according to the new curriculum. So please take some time and ensure that you as a lecturer are familiar with the content and you are applying and teaching the new curriculum in your classroom. Thank you, colleagues, from my side. Again, I wish you all the best.
Yeah, thanks. I think that's a very important point to end on. The curriculum implementation date from Mechanotechnics N6 is trimester 3, and your exam for that will be based on the new curriculum. So you will have to get new textbooks for this subject. So all the best for the rest of the year, and thank you very much. Goodbye, everyone.
Thank you again, and thank you to Macmillan and Tropant for, you know, always being there for us as lecturers and giving us these useful webinars that really make our jobs much easier. We really thank you and Macmillan and Tropant.